Hey, so we're going to be looking over coterminal and reference angles today. We're going to go over those definitions really quick. I'll give you my little definition for it really quickly, some examples. We'll go through that, and then you guys can work on your assignments. But today, we're going to start off with some coterminal angles. Coterminal is actually kind of a word that's going to be put together. It's two words, co and terminal, right? And so if you think of those two words, co means like alongside with or with someone else, like when you play a video game and it's co-op, right? You're playing with someone else. And terminal just means to end. So coterminal angles really are angles that end together. And that's what we're going to be doing today, all right? So let's take a look here. I have this example written here. I'm just going to draw a quick sketch. So for instance, if I draw a 45-degree angle, let's say, 45-degree angle, that's just the angle, but now I need another angle to be a co-angle, right? But I want it to end at the same place. So if I went all the way around this way and then stopped at the same place, that's coterminal. Well, where would that be, right? So if I went from the x-axis and rotated all the way around until I stopped at that same 45-degree angle, that would have to be, let's see, 360 plus the extra 45 is going to be 405 degrees, right? So 405 degrees and 45 degrees are coterminal because they go and they stop at the same spot. We have that same example here with 30 degrees. This is the terminal side because that's where they're stopping or where they're terminating, they're ending there. It is 30 degrees from the x-axis, but if we rotate it around all the way 390 degrees, we'd end up in the same spot. So 390 degrees is coterminal with 30 degrees. But remember that we can also go in the negative direction. If we rotated negative 333 degrees, we terminate at the same side, at the same angle as well. So all of these things, negative 330, 390, and 30 are all coterminal with one another. And that's what this description is just saying here. Right here, sorry, for example. So to find, this is a great point right here, to find a positive and negative angle coterminal with a given angle, you can either add or subtract 360 degrees if it's given to you in degrees, or you can add and subtract 2 pi, because that's basically what you need to do. You just need to do a full rotation on that angle again to get to the same spot. So we'll be adding or subtracting 360 or adding and subtracting 2 pi depending on whether or not we're working with degrees or with radians. Reference angles, we've kind of actually talked about already in class, but let's talk about what reference angles are. Anything in the first quadrant is actually going to be a reference angle of itself. Basically, a reference angle is this. It's an angle that is closest to the x-axis of the one you've drawn. So if I draw an angle here, and I draw this out here, and I say, hey, this is 60 degrees, like the example over there, then the reference angle, well, 60 degrees is the closest to the x-axis, right? So that's going to be also the reference angle. If I were to have drawn all the way out here to, say, 145 degrees, the reference angle would be what gets us closest to the x-axis. So what would get me from 145 degrees to the rest of that angle, which would be 180 degrees, right? So that would be 35. 35 plus 145 would get me to the 180 degree angle. This is the reference angle, okay? So in quadrant 1, all the angles are their own reference angles. In quadrant 2, if we graphed an angle 120 degrees, then we just have to go down to the closest x-axis, which would be an additional 60 degrees, or 180 minus the 120. In the third quadrant, we're graphing 240 degrees, and the reference angle would be found right here, right, which would be 60 degrees, because that would be, again, 240 minus the 180, which would be the 60 degrees. And then right here, 315 degrees. If we graph that all the way around, the closest to the x-axis would be right here. In this case, because we're in the fourth quadrant, it's probably easiest to take the whole 360 minus the 315, which would give us the 45-degree reference angle. So there's three things that we need to be looking for. We need reference angles, we need a positive coterminal, and a negative coterminal, right? And those are all listed out what they are. The reference angle is RA, positive and negative coterminals are referenced by PCT and NCT. All right, so let's take a look at these. Negative 130 degrees is going to be negative direction this way, so we're going to end somewhere over here. And this is just a sketch, okay? So that's negative 130. To get the reference angle would be right here, and that would be a full negative 180 if we went all the way. So this would have to be a 50-degree angle right here to make that a full 180. So your reference angle is 50 degrees. Positive coterminal, we're just going to take the negative 130 and add 360 to that. Remember, that's how we can find a positive coterminal. We can add or subtract the 360 when we're given an angle in degrees. And you can use your calculator to do that if you need to. You can grab your calculator, or you can head on over to Desmos to do this addition really quick for you. I got 230 degrees. That would be a positive coterminal. A negative coterminal, we can easily just subtract the 360 from it. So negative 130 minus 360 gives us negative 490. And that's a negative coterminal angle. Okay, so it's not too bad. Let's try one with radians. Remember, graphing radians is just a little bit of work to get everything out. The denominator tells me how many pieces that I need to graph in the half circle above. So if you think about this like a circle, that's a horrible circle, sorry. We'll call it a circle by definition. I'm going to break the top half into 6 pieces and the bottom half into 6 pieces. So I'm going to cut it in half, and then I'm going to need to cut this side into some even pieces, just something like this. Again, this isn't the greatest. And then I'm going to reflect that down below. Here, here, the y-axis, here, and here. And we need to count 5 pi 6. So we're going to count 5 of these. So this is 1, 2, 3, 4, 5. So from the initial side to the terminal side, that's 5 pi 6. We need a reference angle. If this right here is 5 pi 6, that must mean that this is a pi 6th, right? Because each of these sections is a pi 6 long, right? So the reference angle is a pi 6th. Again, if you really need to, you can convert all these to degrees. Graph it in degrees. Just convert all your answers back to radians, because this is given in radians, so the answers should be in radians. Positive coterminal would be 5 pi 6ths plus 2 pi. Now, if you don't know how to do that in your calculator, basically just do 5 6 plus 2 and then get your pi back in there. This is the same thing as 5 pi 6 plus, we're going to take 2 pi and write that as 12 over 6, because 12 over 6 is 2 pi, and because my denominators are the same, I can add my numerators and get 17 pi 6th. Okay? For your negative coterminals, you can do 5 pi 6 minus your 2 pi, and do the same conversion here. That would just be minus 12 6, right? 12 pi 6, which would be a negative. 5 minus 12 is a negative 7 pi 6. All right, next up, got a couple more here. The next one, you should try these next 4 on your own. I'll cover those in the next video, though. How about that? Go ahead and try these next 4 on your own, and if you need some help, go watch those videos. All right. If you do need any help, though, or any understanding on how to do all this, go ahead and pause the video and go ask your teacher. Okay. Ask your teacher any questions you may have, but that's your job. If you don't understand it, go seek the understanding. All right. Y'all have a good one.